In complex systems, taking the most logical, intuitive action will sometimes cause the exact mechanism you are trying to control to shatter in your hands, delivering the precise opposite of your intended result. When mid-century American farmers adopted a massive technological leap in harvesting machinery, their crop yields skyrocketed. The logical outcome should have been immense wealth. Instead, the resulting harvest actively bankrupted the farmers who adopted it. When a global oil cartel intentionally slashed their own production output, they had far fewer barrels to sell. Yet by artificially crippling their own supply line, their total revenue exploded. And when local law enforcement successfully executes a massive drug bust, pulling thousands of pounds of narcotics off the street, the immediate measurable result is a sharp spike in local property crime and violence. These three outcomes look like glitches in reality, but they share a specific mathematical threat. In each case, the people in charge rely on the standard assumptions of supply and demand to guide their actions. To understand why these systems broke, we have to look past the volume of goods being produced or destroyed and measure a hidden variable, the exact price elasticity of demand. The baseline assumption of modern economics is straightforward. Increasing efficiency and expanding supply leads to lower prices, wider access, and ultimately healthier markets. This animated graph shows a standard market expansion. When production increases, we visualize it as the supply curve shifting to the right along a downward sloping demand curve. The price falls, and the quantity sold goes up. The expectation here is that the larger total volume of sales will easily compensate for the lower price point per unit. But in certain specific markets, executing this mechanical intervention mathematically self-defeats. Looking exclusively at the raw volume of supply is dangerous. It ignores the variable of human behavior, specifically how intensely a buyer needs the product. A policy's success is not determined by the amount of goods you push into a market or pull out of it. It is determined entirely by the behavioral responsiveness of the buyers on the other end. In economics, that behavioral responsiveness is rigorously defined as price elasticity of demand. It measures exactly how much the quantity demanded reacts to a change in price. Because we calculate it as a ratio of percentage changes, it is entirely unit-free. This allows us to accurately compare human behavior across vastly different markets, from heavy machinery to soft drinks. The equation is the percentage change in quantity divided by the percentage change in price. When that resulting number is less than 1, we define the market as inelastic. This means buyers respond only slightly to extreme swings in price. Real-world inelastic goods share specific criteria. They are strict necessities, they lack close substitutes, or they possess physically addictive properties. If the price doubles, consumers will still buy almost exactly the same amount because they have no other choice. Contrast this with a highly elastic good. If the price of one brand of soda rises by 20%, buyers will instantly switch to a readily available substitute, driving the quantity demanded into the floor. Elasticity dictates exactly how hard a market fights back against your attempts to alter it. To see how this breaks our baseline assumptions, we have to establish the unbreakable rule of market accounting. Total revenue equals the price of a good multiplied by the quantity sold. This diagram shows two side-by-side markets testing the exact same price drop. Graph A features a flat demand curve, representing highly elastic consumers. Graph B features a steep, near-vertical demand curve, representing inelastic consumers. We establish identical starting revenue for both markets at identical initial prices and initial quantities. Watch what happens when we initiate a downward price shift in the elastic market. Volume surges as buyers quickly flock to the cheaper price point. The policy succeeds. The massive surge in quantity easily outpaces the slight drop in price, and the total revenue box expands. Now we apply the exact same downward price shift to the inelastic market. Because the good is a necessity, buyers are already consuming what they need. Their habits barely change. We hit the inversion. The tiny incremental increase in volume completely fails to cover the massive loss in price per unit. Total revenue collapses. This gives us a formal mathematical rule. If demand is inelastic, price and total revenue move together. In an inelastic system, Pushing more volume into the market to lower prices is mathematical suicide for your total revenue. We can now map this rule onto the American farmer in the mid-20th century, as the industry experienced a massive boom in agricultural technology. This chart models the agricultural reality. The new technology successfully achieved its goal, shifting the global food supply curve sharply to the right. But basic food is a necessity, which means its demand is highly inelastic. People do not eat 3 times as many meals a day just because wheat is cheaper. The quantity consumed barely moved, so the price of wheat crashed. The math took over. The severity of the price crash heavily outpaced the minor increase in volume. Overall, farming revenue plummeted. The tragedy of this result is one of isolation. Each individual farmer had to adopt the new harvesters just to survive the falling prices. But collectively, their combined efficiency destroyed their own market value. Technological efficiency does not guarantee economic survival if the underlying market cannot stretch to absorb it. We can pivot this model from agriculture to a far more dangerous arena, the illicit drug trade. Due to the physical realities of addiction, the demand for illicit drugs is practically vertical. It is perfectly inelastic. The intuitive government response to this problem is drug interdiction, intercepting shipments and aggressively cutting off the supply at the border. This chart visualizes the bust. Shifting the supply curve left against a near vertical demand curve means street quantity drops slightly, but price spikes exponentially. In inelastic markets, price and revenue move together. By restricting supply, the illicit market's total revenue explodes. The addicts must now fund this massive expanded revenue box to secure the exact same amount of drugs. The predictable, mathematical outcome is a local surge in property crime, theft, and violence to cover the higher street prices. Good intentions targeting the supply side actively worsen the social outcome because they fight directly against the mechanics of an inelastic system. The mathematically sound alternative requires abandoning the attack on supply. Policy must instead target demand directly through rehabilitation and education. Moving the demand curve changes the math entirely. When education reduces active users, the steep demand curve shifts left. This achieves the dual goal. Both street price and quantity consumed fall simultaneously. Consequently, the illicit market's total revenue collapses and the violence evaporates. A foundational axiom of economics is that people face trade-offs. There is no such thing as a free lunch. Every policy exacts a strict mathematical cost based on the environment it enters. Intuitive, heavy-handed actions fail because they assume humans act as passive recipients of supply, but buyers are calculating variables. To successfully alter a complex system, you cannot force your will upon its supply. You must calibrate your strategy to the exact elasticity of the market you are trying to change.